Okay, so let's look at this problem. From 0 to pi over 18, 2 cosine to the power of 4th 3x over square root of 1 minus sine 3x dx here. Okay, so this problem is a little tricky one, and you know, the idea for solving this problem is we need to use a conjugate to multiply it. Okay, so it turns out this is what I can do first. So since x is from 0 to pi over 18, and the corresponding 3x is going to be 0 to pi over 6. Okay, so sine of pi over 6 is going to be 1 over 2, and corresponding cosine of pi over 6 is going to be a square root of 3 over 2. In other words, no matter sine 3x or cosine 3x, between 0 to pi over 6 is going to be a positive number. Okay, so for here, this is what we can conclude. So no matter what, cosine and sine 3x under this interval is going to be strictly greater than 0. Okay, so with that in mind, what we'll do first is we're gonna step 1, we're gonna multiply square root of 1 plus sine 3x over square root of 1 plus sine of 3x to the integrand. So this is what I mean. So that is integral from 0 to pi over 18, 2 times cosine to the power of 4th 3x over square root of 1 minus sine 3x times square root of 1 plus sine 3x over square root of 1 plus sine 3x and then dx. Okay. So it turns out the denominator is going to be 1 minus sine squared 3x. Okay. And that is 2 times cosine 4 3x times square root of 1 plus sine 3x. Like we said, on the bottom it's 1 minus sine squared 3x, and then they're going to give you its cosine square 3x. Okay, since 1 minus sine square 3x is cosine square 3x, and then dx. And also, since cosine 3x is greater than 0, as we just discussed, so we can you have square root, you have a square, since it's positive, so just the cosine 3x dx here. Okay, and then after that, what should we do? Well, this is what we need. So up to here, we got cosine cubed 3x times square root of 1 plus sine 3x dx. Okay, so this is so far what we can get. Okay, and this step is really important because it simplifies the integrand in a different way. Step 2, okay, we're going to apply a u substitution. So for here, we're going to set our u equals 1 plus sine 3x. Okay, and correspondingly, when x is 0, u equals 1 plus sine of 0, which is 1. Okay. When x equals pi over 18, u equals 1 plus sine times pi over 6, which is going to be 1 plus 1 over 2. That is 3 over 2. Okay. And then also u equals this. Correspondingly, du going to be 3 times cosine 3x dx. Okay, dx. When we have this, we're starting to make the u substitution. So the new integral is going to be from 1 to 3 over 2. Okay. So for here, guys, you need to do a little bit more here because we have is, well, let's write, hold on, let me write into this way. So for the original integral from this step, this is what we can do here. We can have cosine squared 3x times 1 plus sine of 3 sine 3x, and then times cosine 3x dx. Okay. And then what we can do, excuse me, so it's from 0 to pi over 18, 2 times 1 minus sine square 3x. Okay. And then times 1 plus sine 3x times cosine 3x dx. So in this way, it's more clear because we can make the u substitution here, cosine 3x dx. We can also handle it here. Okay. So we need a new page. So continue with what we have. Well, maybe let's do this. This is better. Continue with what we have here. Let's see. We're going to have from 1 to 3 over 2. Okay. Let me do it here. So 1 to 3 over 2. And then this is going to be 2 times 1 minus sine squared 3x. Keep in mind, our u substitution is u equals 1 plus sine 3x. So we can solve sine 3x for u. That is u minus 1. Okay. So in other words, this is going to be 1 minus u minus 1 squared times, this part is square root of u, and the cosine 3x dx is going to be du over 3. Okay. This part is going to be du over 3. Okay. So let me introduce a little bit about here, guys, because u equals 1 plus sine 3x, then we can get that sine 3x equals u minus 1. So that's why we, replace u minus 1 here. So it turns out this is from 1 to 3 over 2. We have 2 times 1 minus, for this part, let's still have u squared minus 2u plus 1. Maybe start to use bracket. Okay. This is going to be u to the power half. And of course, you have a times 1 over 3 times du. Okay. And then we can start to simplify it a little bit. So first of all, let's bring those 2 over 3 out, which is 1, 2, 3 over 2. This part you have 1 minus u squared, so it's going to give you it's minus u squared plus 2u. 1 minus 1 is 0. And then times u to the power half on du here. Okay. And then we can do is we can have 2 over 3 from 1 to 3 over 2. This is going to be negative u to the power of 2.5, which is going to be 5 over 2, plus 2 times u to the power of 3/2. And then du. Okay, and then du. it turns out after here things gonna be very, very straightforward. So you integrate this as a negative u to the power of 7 over 2 over 7 over 2, right? And then plus 2 times u to the power of 5 over 2 over 5 over 2, and then evaluate it from 1 to 3 over 2. Okay. So it turns out, let's see, the calculation might be a little bit complicated, okay, but you got the point, which we can substitute this in. So let's see, we have 2 over 3. So this is over, over 7 over 2, so it's going to be 2, so we have a negative 2 times 3 over 2 to the power 7 over 2, and then over 7, plus 2 times, you're going to have 2 times 2, flip it, times 3 over 2 to the power of 5 over 2, and then over 5. And then minus 3 over 2. This part is easy. It's going to be negative, because this part is 1, this part is also 1. So it's minus negative 2 over 7, and then plus 4 over 5. Okay, 4 over 5. And then, of course, you can do some simplification, but after here, I think I can skip that part because all the rest is purely calculation. But the central idea for this example is, use this conjugate, and then to simplify the problem as we discussed, and then in step 2, to make a U substitution to make things work. Okay, so yeah, so I'll stop here and hope you enjoy this video. Thanks.